For 100 trillion years, stars will form.
And then the universe goes dark, forever. A slow, cold end is waiting.
So, how does it all actually end? Well, science has three main theories. Each one is, well, oblivion. You see, the fate of our universe is a battle. It's this epic cosmic tug of war.
In one corner, you've got dark energy. It wants to push everything apart. And in the other corner, gravity. It's always trying to pull everything back together.
And get this, a single number decides the winner. It's called the density parameter, or omega. Basically, it answers the question, is there enough stuff out there for gravity to win the fight? Or is space just too empty, letting dark energy run wild forever? That one value decides everything.
All right, so that brings us to scenario number 1. This one's kind of quiet. It's called the Big Freeze, or sometimes heat death.
In this version of the future, the universe just keeps expanding forever. It gets colder and darker and emptier until it hits what they call maximum entropy. Basically, a perfect unchanging stillness where nothing, and I mean nothing, can ever happen again.
So what happens first? The stars die. Yep, they just run out of fuel. One by one, the lights just go out. And that's it. An age of darkness begins. The era of starlight is just over. So then what? Well, for a long, long time, black holes are the kings of the cosmos. But here's the twist. Even they don't last forever.
Yeah, they actually evaporate super, super slowly over unimaginable spans of time. They leak this thing called Hawking radiation until they just fade away.
I mean, look at these timescales. 100 trillion years until the last star dies. And then 10 to the power of 100 years for the black holes to disappear. We can't even wrap our heads around that. The universe doesn't end with a bang. It just sort of fades to black.
Okay, so scenario 2 is the exact opposite of quiet. This one's violent. They call it the Big Rip.
Here, expansion doesn't just keep going. Oh no, it accelerates uncontrollably. The dark energy gets so strong, it just completely overwhelms everything.
So first, it's the galaxies. They get torn to shreds. Stars are just flung out into the empty void.
Next up, stars and planets. They disintegrate. Nothing, absolutely nothing, can hold itself together against this force. And in the last, final moments, even atoms are shattered. Everything becomes unbound. The very fabric of space and time, it just rips apart. All right, our third and final possibility is a total 180. It's called the Big Crunch. It's basically the Big Bang, but in reverse. So in this scenario, gravity finally wins that cosmic tug of war. The expansion of the universe grinds to a halt, and then it goes backwards. Everything, galaxies, stars, all of it comes crashing back together. It all collapses into one tiny, incredibly hot, dense point, a singularity, the complete opposite of how it all began. So you've got the freeze, the rip, and the crunch. Which one is it going to be for us? Well, right now, all the evidence is pointing in one direction. What we're seeing is that the universe's expansion is actually speeding up, and its overall shape seems to be flat. Put those two together, and it really looks like there's just not enough gravity to ever pull things back. So, the most likely outcome? The Big Freeze. Yeah, the consensus among cosmologists is pretty strong on this one. It looks like our universe is just going to keep expanding forever. A long, slow fade into eternal darkness. But, and this is a big but, we really don't understand dark energy. Not really. What is it? What if it's not constant? What if it changes billions of years from now? If it does, could our final destiny change with it?